Okay, grade 11s. Let's continue with parabolas. So drawing of parabolas. Let's start with your the one that you know, because you're going to have two basic starting points, starting positions, and both of them have advantages and disadvantages. So let's look at the one you know, starting with a graph that has this following standard form: ax squared plus bx plus c. Okay, so first things first, your c value is automatically your y-intercept. So that's what you immediately know. Why? Because when x is 0, you get 1. The second thing you need to do is you need to make y equal to 0 and then factorize to get your x-intercepts. Okay, so that's the next step. So this is step number 1. This is step number 2. And again, to factorize, you might be able just to get the factors just by normal factorization, or you might have to use the quadratic equation. Okay, so you will have to look at your how can I say? You're gonna have to look at your function to determine which one you're going to use. Okay, so that's the second step. The third step is to get the turning point, and in order to do this, we are going to say x equals minus b over 2a. Now, I'll show you in grade 12 why this is, but a very easy way to remember it is by just looking at your quadratic equation. Do you remember that when the discriminant, that b squared minus 4ac is equal to 0, you've got equal roots, real but equal roots, okay? So that means if it's and when that happens, you know the turning point will be on the x-axis, right? So that basically means when you have a discriminant equal to 0, your x value will be the x value of the turning point. So remember that, and this is in all cases, not just when it looks like this. This is just to help you remember. So if you ever forget this formula, which makes your life so much easier, just look at your quadratic equation. Minus b over 2a if that is 0, and you have it. So first of all, for the turning point, calculate the x value by using this. Then substitute this x value into your normal equation to get the y coordinate of the turning point. So that means you have the y-intercept, the x-intercept, and the coordinates of your turning point. Let's do a quick example. Draw the graph of the following. This is exercise 3 number 1a. Y equals x squared plus 8x plus 12. Okay, so first things first is our y-intercept is equal to 12. We can immediately see that, right? Now we make y equal to 0 in order to get our x-intercepts. And this is a nice and easy one. We can just factorize. You can see it works out perfectly fine. Therefore, x equals negative 6 or x equals negative 2. Okay, so these are x-intercepts. Now we work from here and we say for our turning point, please write it out. This is just for me explaining, but you have to write it out when answering a turning point. X equals minus b over 2a, and this will be equal to minus 8 over 2 times 1, so it's negative 4. Okay, so now we can calculate y when negative 4 is the value of x. And funny enough, when x is equal to negative 4, in this case y is also equal to negative 4, and that gives us the coordinates of our turning point. So this graph will look like this: 4, negative 4, that will be negative 2, negative 6, and that will be 12. So there you have everything that you need from this graph. Okay, now we're going to look at the second point of reference, okay, and that's the form a times x plus b square plus q. So let's have a look at what is. Okay, first of all, the a tells you the concavity, meaning if it's concave upwards or concave downwards. Positively concave, like a smiley face. Frowny face, negatively concave. So this tells you the shape, just like the A told you the shape of the graph with the normal ax squared plus bx plus c. Now, these two, as you would remember, the P and the Q, from the previous video, this is it would tell us the coordinates of our turning point, right? So whatever that P is, the negative of it will be the turning point in this format. Okay. So immediately you have the turning points, and you can tell that this graph, how it's going to look like. Okay, so what would be the steps that you take? First of all, you can get the y-intercept by making x 0. So that will again be your first step. Okay, but in this case, it's not just going to be q, because q represents the translation of the graph. Remember now. So first step, make x equals to 0, and that will give you the y-intercept. That's your very first step that you take. Second step, you can clearly see the turning points, okay? But you don't have to do that second. You can make y 0 and get the x-intercepts as a second point as well, because you will identify this structure from completing the square, right? So we just make y 0, solve for x, and then we have our x-intercepts, and then thirdly the turning point, and that is how we are going to determine the turning point, just from the actual form. Okay, so this is how you approach it. So let's do an example. So the example will be y equals bracket x plus 4x squared minus 4. We're starting easy, okay? So now, first things first, you make x 0. So y equals 4 squared minus 4. Okay, the 16 minus 4 is 12. Okay, and this is our y-intercept. Then secondly, we are going to make y 0, and then we will get our x-intercept. So we take the 4 across, so it will be 4 equals x plus 4 squared. We take the square root on both sides, so this will be plus minus 2. Please remember the plus minus. And over here is just x plus 4. And from here on we know that it would be negative 4 plus minus 2 equals x. And from here on, when we do our calculations, you will see therefore x is equal to negative 4, negative 2 is negative 6, or x is equal to negative 4 plus 2 is negative 2. And there you have our two x-intercepts, and we already know what the turning point will be. Remember, it's a negative of that number. Okay, so it is negative 4 and that number, negative 4. So our turning point, we already know, is negative 4, negative 4. Okay, now we can immediately draw the graph where our turning point is negative 4, negative 4. Our x-intercept is negative 6, negative 2. And our y-intercept, as we've calculated there, is 12. And you will recognize that this is exactly the same graph than what we just did from the other format. So I wanted to show you the same example starting from two different points. So that's basically the two standard forms that we're working with. And now I would like to show you how to move from one form to another. And this is revision. We've done this in chapter 2 in the beginning of this year. But let's say you have this equation, and this would be relevant for exercise 3 in your textbook. Let's say you have this equation, and they're asking you, please convert it from the one format. They will tell you this, ax squared plus bx plus c, to convert it to a bracket x plus b squared plus q. Please note, those two a's are exactly the same. That's why they use the same symbol. The c and the q, they are not the same. That's why they're using different symbols. So please keep that in mind. These two are the same, but these aren't not. Okay, so this is what we're doing now. We're going to complete the square in order to answer this. Okay, so first things first, this is not equal to 0, so we cannot cancel something out. We can factorize by taking it out, but we cannot cancel it out. Okay, so let's start. And that would be our first step. Take out the negative 5. So then it will become x squared minus 4x minus 3 over 5. And we have to do this in order to have an a inside the bracket to be equal to 1. Otherwise, we cannot complete the square. Okay. So second step. And for the rest of this, you just leave the negative 5 outside. Okay. So the next step would be to add whatever minus b over 2 squared is. Okay, so you remember this is now technically our b value, the negative 4. So b over 2 is negative 2 and b over 2 squared is 4. So this is what we are going to add. Okay, I'm doing this in a different colored pen. So plus 4 minus 3 over 5 minus 4. Okay, and to help us identify the perfect square, I'm just putting a bracket around that just for you to understand. Okay, now next step, negative 5, block bracket, bracket. Now we can immediately write this as minus 2 squared, x minus 2 squared. Okay, then minus 3 over 5 minus 4 is minus 23 over 5. And it's to your benefit to keep this as an improper fraction. Please do not write this as a mixed number. It's just going to confuse the whole process. Please write it as an improper fraction. Okay. Now we are ready to multiply the 5 back into this bracket, right? So now it becomes negative 5 bracket x minus 2 squared. So it's multiplied to the first part. Now it's multiplied to the second part. So it becomes plus, and the 5's cancel out, plus 23. And here you go. This is that equation minus this one, minus 5x squared plus 20x plus 3, converted into this format. So let's look at what information we have from both of these equations. Okay, so from the top one, we can get the y-intercept as 3. So y-intercept is equal to 3. Then from either one, we can calculate the x-intercepts. Okay, I'll most probably use this one because it's much easier for where we're at. Okay, so I'll show you how to do that now. And then thirdly, we have the turning point. So turning point is 2. Remember the negative of that value, right? It's minus 2, so it becomes a plus 2. And 23. So we've got the turning point, the y-intercept. And now let's quickly get the x-intercept. So we make it equal to 0. So minus 5 bracket x minus 2 squared plus 23. So we take the 5 across and divide by 20. There we go. Now we take the square root on both sides. So you'll have a plus minus square root. Let me just see. This is the other way around. My apologies. It's 23 over 5. It was a negative 23 divided by a negative 5. So 23 over 5 equals x minus 2. So therefore 2 plus minus square root of 23 over 5 is equal to x. So there you have your two x-intercepts. So you can see how we got all the information we need to draw these graphs.